working in Milan for a startup called Casavo. And today we will speak to you about how we learned that we had to use some geospatial data and what tools we found useful and to find this data and to store it and to analyze it. So before going deep into that, I just wanted to give you an overview of what we do, what is Casavo, and what we do there as data scientists. So Casavo is a startup based in Milan. It's an instant buyer. This means that the main activity of the company is to buy apartments, renovate them, and then resell them. So the advantage for our customers are for the persons that want to sell an apartment. The advantage is that we guarantee that we buy the apartment in 30 days, which is a lot less than the average in Italy. So in Italy it takes between 3 and 6 months most of the time. And for the person that buys the apartment from us, the advantage is that they buy a renovated apartment. What we do as data scientists, so until now we mainly worked on what is called the valuation platform. The valuation platform is a tool that is running currently on the website of the company, where our customers can go write information about their apartments, and after around 1 second they will get a price that Casavo would be willing to pay for their apartment. We built this, we started in June more or less. We built it from scratch. I don't want to go into much detail about the model we used. I can just tell you that it's a machine learning model based on regression and gradient boosted trees. But on top of this model, we use something that is called comparable transaction analysis, which basically means that for a target apartment that we want to get the price of, we look around the apartment on a radius of, I don't know, let's say 500 meters. And we apply these regression models on these apartments. And then we do some kind of averaging and data analysis. But from this, I just want you to get the idea that the location of the apartment is important, because we have to find this radius, we have to find the distance from our target apartment to the apartments that we already have in the database. So location is very important for our model and for the valuation. So we use 3 types of information in order to build this model. First are the characteristics of the apartment. I mean, this makes sense, right? So things like how big is the apartment, on which floor is it located, what is the status of the apartment, is it renovated, is it not renovated, and so on. So for example, you might imagine that an apartment on the 6th floor in a building without an elevator is going to cost less than an apartment on the 1st floor, let's say. Another important information is the area, so where is the apartment located in the city. Usually in Italy, every city has the area splitted, so there is a map available from City Hall that you can download with these areas. And the third that we thought was useful was the distance to points of interest. So things like the distance from the apartment to the closest subway station or the closest park, or is there some train passing right outside your window? So these are all things that could influence the price. So for things like the characteristics, we had this information from our customers, from our internal database, but for the other 2 types of features, we had to find it somewhere else. Okay, just to test you a little bit, I gave you some hints. What do you think are the 3 most important rules of real estate? Does anyone have a guess? Yes, good. Good, you guessed. So yes, location, location, location. So yes, like I mentioned before, it's important to know the area of the apartment and what are the points of interest around. And maybe you don't want to be this guy, or maybe you do, I don't know. Okay, so in more detail, when we started searching how to do this, so how to find this information, how to store it, how to use it, we saw that every software we were looking at had this GIS inside the name. So we're like, okay, this GIS must be important. So system. And it is a system designed to capture, store, manipulate, analyze, manage, and present all types of geographical data. And there are different softwares that help you do that. So for example, Nicolas will talk about PostGIS, which is an extension of Postgres and that helped us store and also manipulate the geographical data. We used a bit QGIS, which helps visualize geographical data. So there are quite a lot of tools like this. Okay, geospatial data can be of two types. So vectors, which are things like points, lines, or polygons, and these are this is data that has exact location and hard boundaries, or rasters, which is more like continuous data without hard boundaries or exact location. We will talk only about the vectors today. So, vectors can have different formats. One of these formats is a shapefile. So you remember I mentioned before that we needed the information about the area where the apartment is located. I said that we downloaded this from the websites of the city hall of each city where we operate. And these came in as shapefiles. These are some special kind of files for storing geographical data, and they are supported by most GIS software, and you will see later how we manage them. For the other type of data that we needed, so for the points of interest, we decided to go for OpenStreetMap, which is basically like Google Maps but open source. And it's called by some the Wikipedia of maps. So the idea was we needed to download and save data about these points of interest. So we realized it wouldn't be very useful to every time someone asks for evaluation on our website to go and search for these points of interest, like to call the API and go and search for these points of interest. So we decided for each city where we operate, we need to download them and store them somehow. The good thing about OpenStreetMap is that the data is free for anyone to use. You can improve it. If you see something is wrong, you can improve it. I mean, it's open source. And data can be of three types. So there can be nodes or points. These are things like the train station, the subway station, a school, things like that. There are ways which could be closed or open. So closed ways are things like a park or a garden. Open way are streets or train platforms. And the third type is relation. And relation, you can see here an example, are the zones, so the areas of the city. Okay, so amazing. We can do this on OpenStreetMap, but how do we actually do it? So there are different tools like Overpass Turbo, for example, where you can write a query and you run it and you get what you can see here on the right. So here the query is to find all the parks in some area, and you can see here that it found them. But the problem, like I said, is, okay, it's here, but how do we put it in how do we start using it? How do we make it, usable? So actually Overpass Turbo allows you to store this data as a GeoJSON, for example. So you can see here an example of what it looks like. So it's geometry, it's a type of type polygon, and then you can see the coordinates like latitude and longitude for this polygon. Okay, great, we are one step further, but now we also need to store it. So the idea would be to store it in a database that looks something like this. So you know, you have, okay, this polygon is located in Milan, it has this ID, and it represents a park or something like that. So now Nicolas will give you more detail about how we actually did this.
Okay, thank you. So yes, as Ioana was saying, it's when you have that many polygons and shapes, like all the parts of Milan, all the streets of Milan, all the railways of Milan, it's a lot of things that you have. So for sure you want to store it in a proper way. So the idea was to store it in some database. Actually, you could think, okay, I have my, I don't know, SQL database. If I want to store all the subway station of Milan, you could say, okay, I can have a column called latitudes, a column called longitudes, and I just have two floats column and could work with it, which is true somehow. But actually, very quickly you're going to realize that it's going to be very hard to handle, especially when you start to handle things like parts. You can, okay, store all of JSON in your database, but then how do you do all the calculations, all the distance between 2 points, for example, or 2 polygons. So that's why we discovered that actually most main SQL database have some special extensions that allow you to handle all those things in a much easier way. MySQL has some. We decided to use PostGIS for several reasons. So first thing, actually, we were already using PostgreSQL, so PostGIS is there for free, let's say, if you want to use it. And also, I think it's the most advanced one. It does some very specific optimization that actually were really helpful for us. I will mention it later. So once you use those special extensions, what does it change for you when you have this SQL database? What you can do actually is define new types of variables. You don't have only like floats, integers, strings, or arrays. You can have also polygon type, point type, line type, those kind of things. And with all those new data types that you get, we also get a lot of new functions that you can use directly. Functions such as, okay, I want to know what's the area of the polygon I store, or I want to know distance between 2 points. I want to know if 2 polygons intersect each other. So here, I guess you can already see that if you would store everything in just latitude and longitude, then you have to write yourself your code about how, when do polygons intersect each other. It's really quite complex thing. So this helps you a lot. So now I'm going to show you two very simple queries that we do actually all the time for our use case. So that's why I would like to mention them. So as I was saying, at the end of the day, when you want to evaluate the price of an apartment, the first thing you do, okay, you look where is it located, and what we do, we look, okay, what are the 10 closest apartments to this apartment? So to do that, what we do is like in a database, we have a table which contains from every line the apartment for which we know the price, and we know actually the coordinate of this apartment. So we stored a coordinate variable in this point table, a point column, sorry. And thanks to that, we can actually easily use some function which is called stdistance in the PostGIS to calculate all the distance between all the apartments you have in your database, which can be very, very big, and the point that you're interested in, like the apartment you want to evaluate. So again, this, in theory, you could say, okay, I just take latitude and longitude, I do some Euclidean distance, nothing so fancy, why do you bother with all of that? But I think it's going to be clear maybe for the second example. Another thing we want to know, every time we evaluate an apartment, we want to know to which zone this apartment belongs. So I think now you can already understand that it's a bit harder just knowing all the coordinates of the point by yourself, writing your own function to understand if it's this point it belongs to a zone is already much, much harder. And here again, you just have to define a column, which is a polygon column, okay, that you can read directly from the GeoJSON, and use the intersect function, and directly you're going to have your answer if your apartment belongs to this zone or not. So it's even better than that actually using PostGIS, because there's two kinds of people in the world actually. There are flat earth people, and then they have people with very weird theories saying that the Earth is actually a sphere, and actually when you want to calculate distance between 2 points, you should do very fancy trigonometric calculation that actually nobody wants to do. So the good thing is like PostGIS is actually agnostic about that. So if you want to keep it simple and you say, okay, the Earth is flat, I don't care about being very precise, anyway I work on a very local type, and all you have to do is like when you create your column and PostGIS, you just have to declare, okay, I want this to be a geometry type. So when you do that, calculations are going to be faster, but it's going to be less precise. If you want to go more fancy, it's very easy. You just say, okay, now I'm going to work with a geography type. You just declare it as a geography, and it's going to be all the calculation with those crazy 3D things, because those weird people, apparently they are right, that this is going to do everything for yourself, which is already much, much simpler. And that's a third thing for which it's even better to use PostGIS. This thing is called a spatial index, because you know that in SQL usually if you want to be efficient, you better put some index on some of your columns if you want to do joins, for example. And there's a similar concept that you can apply in geospatial database. So the main idea, yes, like every time you store a polygon, for example, in this database, what PostGIS is going to do is going to draw around those polygons the bounding boxes. So from those complex polygons, okay, sorry. So from those complex polygons, you're going to arrive at simple bounding boxes. And instead of storing a lot of information here, you can store just actually for every polygon, you can just store 4 floats. So it's much quicker. You can index them. So it's going to help you a lot. For example, if you want to know, okay, you ask PostGIS, is the green polygon intersecting the blue one? If you start from the line, you should have to do a lot of complex calculation. But actually, if you use the spatial index, you can already see that, okay, since the bounding box are not touching each other, I already know that those polygons do not intersect. And this can change dramatically the speed of your computation. So this helps us a lot. Okay, so now I just spoke about PostGIS, but actually we are in a PyData conference. So now let's speak about Python. So how do you use this thing if you want to read it, launch it from a Python script? So actually there are several ways of doing that. And the way you interact with PostGIS is actually similar to the way you interact with any SQL database in Python in the end of the day. So there are a lot of ways to do it. But since we are data scientists, I don't know for you, but the thing you do all the time is to use pandas. So in pandas you have this read SQL function, and a very easy way to do it is you can declare a string, which actually is the SQL query that you want to do, and you can give this string as an input of the function. You're gonna read, you're gonna get your data frame, which basically represents what is in your database. That's fine, actually, no problem with that. Actually, it's quite simple. I mean, I guess, especially for data scientists, you know, you don't have to bother too much. You know SQL, you do this and you get your results. Maybe it can get a bit trickier. For example, if you want to start, okay, I don't want to query everything. I just want to query some variables, and those variables will depend on some parameters in my script somehow. So you want to have something like, okay, I want to declare a list of variables I want to query, and this will change somewhere in the script. And I still want to be able to, in my SQL query, to query only those variables. So you can also still do this, creating this string, but then you have to be a bit smart, because you can just put the list in your string. You have to say, okay, I have to add commas, because actually in SQL they use commas like this without square brackets. So this is okay, fine. But I guess you can start to see it's going to start to be a mess. And I did this a lot, actually. I even did much worse, you know, because I had also some where conditions with some condition depending, and I became a crazy ninja about string manipulation in Python just to do those crazy SQL things. And then one day, one IT colleague went and he saw my screen. He was like, "Oh God, poor guy, what are you doing to yourself? What are you doing to yourself?" There's some way to do that a bit smarter. Those things maybe may seem more complex in the beginning, but once those things are set up, it's easier. So one possible way to do that is to use something which is called SQL Alchemy. So I don't know if a lot of you are familiar with SQL Alchemy. Okay, so good. So I didn't know that actually not so long ago. So in the beginning it looks a bit strange, because okay, but why do I have to define this strange table object and to create this metadata thing that actually is used? I don't understand what's the point. And in the end, okay, there's a bit of setup to do, but once this thing is done, it allows you to do things much more efficiently. Because for example, if I take back the example of before, I wanted to create just a list of variables. You know, you can just declare a list of variables and then put it directly in the SQL query. You don't have to do any string manipulations. It's just a stupid example, but when you do other things, it can be quite useful. And this is actually a very big topic. I mean, I'm not expert at all at SQL Alchemy. I just use it as a data scientist because I found it very useful in this way. So once you use SQL Alchemy, actually, so since we were speaking about PostGIS, you have to know, okay, how do I do now connect with PostGIS? Actually, it's quite similar, because in the end, what you have, okay, you have PostgreSQL, which is your database. PostGIS is geospatial extension of Postgres. So here we are in the SQL world. If you use Geoalchemy, you can communicate with PostgreSQL, and if you want to use the communicate with PostGIS, you need Geoalchemy. But in the end of the day, Geoalchemy is just an extension of SQLAlchemy that allows you to use all those geospatial extensions. So if I go back to the query we were doing before in SQL, actually I could start to use them using SQLAlchemy and the function of Geoalchemy. So you can see in the end they are not that much more complex. They're quite similar to the other ones. And believe me, when you start to do more complex things, these things is going to help you a lot. So it's quite nice because even though this thing is just a few lines in the end of the day, when you think about all the calculation that is done on the back end, how all the optimization that was done with all the spatial index, how to query efficiently, very quickly the closest apartment that you want to evaluate. For us, it's very important because we want people on the website not to wait 2 minutes to get the answer. We want the answer to be immediate. So this helps us to do this actually without knowing anything a few months ago. We just built everything. Actually, we realized that a lot of tools already available to help us to do that. So that's what we wanted to say in the end of the day. Geospatial data can seem a bit complex when you don't know it. It can be a bit scary, but actually nowadays, there are so many tools that are there to help you that if you want to do it, interested in the field, I say just go for it. Thank you.
Any question? Okay.
I have a question. Can you hear me? Yeah. Okay. I have a question regarding distance calculation. Did you manage to use any API to calculate the distance in a, let's say, proper way? I mean, like, for example, how Google Maps is doing that, or you?
No. For now, we just do the simple Euclidean. Euclidean on it. So we don't do the road calculation. Yes, this could be a later improvement to be done actually.
Okay. And did you do any search about the tools, or let's say good APIs to do that, or you didn't start to?
No, we still didn't start this.
Hi. I have a question because at the beginning you said that you basically download the map and then you use your calculations based on what you download. I want to ask, do you and how often do you update those databases, and do you keep your reference to the previous point? Because let's say maps do update sometime and points do change. How do you approach this?
Okay, actually, honestly speaking, for now, since very new things, we just only did once for the cities, and for now it's fixed. And for sure we're gonna update it later, but it's a problem we still didn't tackle. Now we had a lot of stuff to do before, so for sure we should find a way to manage this in the future. But for now, we don't handle it.
Hello, thanks for the presentation. I have a question regarding the quality of OpenStreetMap. What do you think about it? Is it as good as Google Maps? Do you find it hard to find all the places around the spots?
Well, I don't know. Actually, I was surprised. Personally, I think it's very good. Okay, now we work on the big Italian cities, so maybe we're a bit biased because for now, like for example, in Milan, you have a level of detail of the map is very strong. I mean, it's crazy. Even if you look at parks, you have also the list of benches, the type of benches on which you can sit. So the information is really crazy. It's even actually sometimes higher quality than Google Maps.
Is it included in the model, those benches?
Still not, but maybe in the future.
Thanks.
Hello, I have a question. How big your database is in general? Because you said that you had like a performance issues, but how big was the data set?
So it depends. So we have the dataset about the properties and the dataset about all those polygons and so on, like the parks. I don't remember exactly, I have to say, for the polygons, but I think it's like close to 1 million polygons, I think, something like that. And for the properties, a few 100,000.
Okay, that's it.
Well, you mentioned about two ways of representing the data, geometry and geographical. And in terms of analysis of one particular city, which one model do you use? Well, yeah.
No, but at the level of city, you can go for geometry because it's, I mean, especially the city of like Milan, it's not like the curvature of the earth going to start to influence things, so you can go simple and faster.
Thanks.
Hi, I would have a question about the bounding box you show on the to improve the performance of the calculation you perform on the database, because you show the picture of the star and the bounding box that shows that the star is covered with one line, but in fact the box are covered, but the figure and the blue line do not cross. How do you check these guesses, because it's obviously the false information that these two shapes.
So, sorry, I didn't understand.
You have the star, you have the blue line.
Okay, okay.
You write the bounding box
Yes.
for both of them.
Mm-hmm.
You say that box are cover one to each other, but the figure they are around do not cross.
Yes.
So how would you check this?
Okay, so actually the thing is like, the idea of this is like okay, when you have like 1 million polygons in the database, actually most of the polygons are so far from each other that you don't even want to consider them. The thing is like, if you already want to know, okay, which polygon intersect this point, if you can already very quickly say, okay, we have 10 bounding boxes that intersect each other among those 1 million, then you know, okay, among those 10, now I'm going to start to do the real advanced calculation. So in this way, actually, this thing is useful just to do a filter about what you already know that it's not going to happen. And once bounding box could potentially say that, okay, those two things are intersecting each other, you have to do still the complete calculation. But you already gained a lot of time by not caring about the things that you know from the beginning that they're not going to intersect each other.
Okay, thank you.
Quick question about productionizing of this model. So can you please elaborate more on how this service works? Because you said that it's working live on your website, which allows to do live searches. Yeah, just a little bit more information about this.
Okay, I don't know how much detail you want to know. So basically what we have is some Flask app within Python, so that takes as input, JSON, which is characterizing the apartment with its location. The script is actually calling a database, this geometrical database, to know what are the closest apartments. Database returns what are the closest apartments. Then we do the machine learning on those ones, and we get the final thing. So everything actually runs on AWS. And we rely a lot on Docker to help us to, that's actually what allowed us to put this in production very quickly.
Hi, so I have a question about the PostGIS and whether it's have some tools for visualization of data, or do you have do Python spatial visualizations?
No, actually, so there are several ways to observe it. Actually, there's this, you mentioned this QGIS tool. Actually, from this tool, this graphical user interface, you can connect to PostGIS and visualize directly. But even if you use dbeaver, the SQL editor, actually, it's already integrated. So if you click on one polygon, you're going to see directly a little OpenStreetMap with the polygon that you see. That's a lot of already very nice integrations for that.
Thanks.
Okay, is there anyone question? No? Okay, thank you.
Thank you.